All right, guys, example 7, the training wheels are off. We are here to ride this bike. Find the real solutions, use exact values of the equation. 3x cubed plus 4x squared minus 7x plus 2 equals 0. So we have no walking us through the process. We are on our own. Find the solutions. Now, how many solutions should we be searching for? Because this is an x cubed, I should have 3 solutions here. Okay, I'm looking for a sheet. Here it is. Even though it does not walk me through the process, I am using these steps here. We're starting with potential rational zeros. We're going to eliminate some. We'll use our calculator to find some. Then we'll divide it out, deal with the quadratic that we have left, and then this time we're not factoring, we're finding the zeros. Okay, so we're starting with our rational zeros theorem. I need to determine my P over Q. So my P here is 2. My factors of 2 are plus or minus 1 and plus or minus 2. My Q is 3. So this is plus or minus 1 and plus or minus 3. So divide everything on the top by 1, and we get plus or minus 1, plus or minus 2. Did all of that one. Now divide everything on the top by 3, and we get plus or minus 1/3 and plus or minus 2/3. Okay, so here I have 8 potential rational zeros, and I have at most 3. So we have too many. Now let's use our graph to eliminate some of these and find the one that works. So type in your equation. And what should we change our x min and max to be? The biggest numbers I have here are this plus or minus 2. So my x min is -2. My x max is 2. So -2 to 2 and then graph. I don't really care how far up it goes. I'm just needing to know where is it crossing right here. Now with this, I can eliminate several answers here. My biggest and smallest, my -2 and 2, I don't have any graph here. So I can eliminate that. And I can also eliminate negative and positive 1 right here. It's not crossing there either. So I have 1 plus or minus 1/3 and plus or minus 2/3 left. And I can see it's all over here positive. So I have nothing negative. So I'm also going to eliminate the minus. So I'm left with 1/3 and 2/3. Now, to be perfectly honest with you, up until this point, this has seemed really silly to do, especially if we're not using that factor theorem, right, and plugging in those numbers. But this is why this is still so incredibly important. This is intersecting here between 0 and 1. And let me go ahead and just zoom in. I'm going to change my window from 0 to 1. And I'm maybe going to change that window a little bit more. And I'm going to go -1 to 1 on my y so we can see how it's crossing. It's crossing and crossing. So I actually have 2 right here, which I didn't think was right, but it is. I guess I usually don't zoom in. Okay, so we have these 2 here. Now, if I was trying to guess these solutions, how many numbers are here between 0 and 1? Okay, there's a lot. There is an infinite amount of numbers between here. And if you want to guess every fraction between 0 and 1, it's going to take you a very long time for you to find the fraction that works. But if I have a pool that I have now dwindled down to just 2 numbers, I can find one of these zeros. So if I hit trace 1 divided by 3, I get 0.2 repeating, so that's not it. So I did trace 1/3, enter, and I got a y that equaled 0.2 repeating. So that tells me this is not it. So let's try trace 2/3, enter, and see what our y is. So 2 divided by 3, and now we have a y of 0. That is my solution right there. And that is why this is such an important step right here. Specifically, when you get fraction and not whole numbers as your solutions, you need a starting point. And I cannot guess every number in between 1 and 0, but when I have a list, I can dwindle it down. So now that we know that my solution here, my real rational solution, is 2/3, now we can divide this out. So I'm going to put 2/3 on the outside. And I have x cubed, x squared, x, and constant, so I don't need any zeros again. Bring down your first one and multiply add. Now, if you don't like multiplying fractions, just use your calculator. 2 divided by 3 times 3 is 2. So you have a 2 here. And so add these together and we get 6. And then keep putting this in your calculator. 2/3 times 6 is 12 divided by 3, so that's 4. Add and we get 3. Multiply -2 times -3 is -6. Divided by 3 is -2. And we get 0. So do it by hand. Do it in your head. Do it in your calculator. But we should get 0, which we already knew we should have got. Okay, but this reiterates that we are good. So here's my constant, my x, and my x squared. So what I have left is 3x squared plus 6 minus 3. I can't use the square root method. So let's try factoring. My a times c is 3 times -3. And my b is 6. What adds up to 6, but multiplies to 9. Pause the video if you want more time to think about it. And the answer is nothing. So when it is nothing, we get to use the quadratic formula. Oops, let me just put quadratic formula. So our quadratic formula, pause the video if you want a moment to try to remember it. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Here's our quadratic formula. From here, my a equals 3, my b equals 6, and my c equals -3. So I have my variables, I have my formula. Let's substitute everything in. You get -6 plus or minus 6 squared minus 4 times 3 times -3 all over 2 times 3. When I simplify this, we get -6 plus or minus the square root of something all over 6. Put this in the calculator. And just as a reminder, I did not need to put the 6 in parentheses because it wasn't negative. But if this was negative, we'd have to put this in parentheses. Okay, and now I need to simplify the square root of 72. Square root of 72 is 36 and 2, which is 6 and 6. So we get x equals -6 plus or minus 6 square root 2 all over 6. And then can I simplify? I'm wanting to know, does the number in front of the plus or minus, the number behind, and the number below all divisible by the same thing? Well, they're all 6, so let's divide them all by 6. So this does not just go away. -6 divided by 6 is -1. 6 divided by 6 is 1. I don't need it. But then we have the square root of 2 all over 1, which we don't need either. Now, if I go way back up here, the question was to find the real solutions. Here are 2 of my real solutions. We have -x plus the square root of 2 and -x minus the square root of 2. So what's the third one? But because this is an x cubed, we know we have 3 solutions. So what is my third solution? And it's what we divided out when we were looking at that graph. So these are my 3 solutions right here. Now, if you're wondering why when I graphed and I did -2 to 2, did I not see another one here? Because we did see 2 of them right here. And it's because I need to zoom out even more. So if I go, let's just go zoom 6 and see if we can see both of them. There's the other one. It looks like it's just past that -2. So now if I check all of these, trace -1 plus the square root of 2, we have a y of 0. And if I do -1 minus the square root of 2, that is basically 0. And then if we wanted to check one more time, that 2/3, we get 0. So this only lists our potential rational zeros. We have to do quadratic formula or square root property to get our irrational zeros.